Here's another problem done by the shell method, but we're also going to do it by the disk method. But anyway, you take this function right here and revolve the shaded region about the x-axis, and it creates a sort of mound of volume. But we're going to do the shell method first. So we take the shells cutting horizontally down or across onto the object, and we get this representative shell, and then we cut that and stretch it out into a rectangular slab and figure out the different dimensions. It's delta y thick. The linked out at a y location out to the curve is just going to be figured out this way. So y is equal to this. So y squared is this. So x, which is this linked across here, x, how far out we are to the cut. Maybe I'll redraw that a little bit there. Oops. That will be this length, actually. That's x out there. Then x is going to solve out to be square root of 1 minus y squared at a y location. And that y location being right here. So that's why the width across here is square root of 1 minus y squared. Then the height is the circumference around here, going this way. And that has to do with the radius. The radius is y. The radius is this y value right here. So that's 2 pi y is the circumference around that circle. So you put those all together, multiplying, and you get the volume of the shell. And you add all those shells up as the y goes from 0 out to 1, creating all the shells. The exact value is here, this integral from 0 to 1. And you can do substitution on that, letting u is equal to, u will be equal to 1 minus y squared, and then things will work out. And when you do that, you'll get 2 pi over 3. Now, interestingly, this problem can also be done with the disk method, and it's actually a little simpler. So let's do that. So coming over to here, same problem done by the disk method. And now you have your cuts going vertically, delta x slices, with the height being the radius being the y, but that's at an x location. That's square root of 1 minus x squared. So the volume of these disks, or slices, or slabs, whatever you want to call them, is pi r squared delta x. So you sum those up from 0 to 1, and you get the exact volume is here. And if you work that out, you get 2 pi over 3, which is exactly the same answer as before. So when you can, for extra practice, do these problems with the shell method and the disk method as possible, or the washer method if there's a hole in the middle. It's all the same kind of idea, and see if you get the same answer.